Okay, so these are the two books. So this is one of the references, but I have already downloaded the soft copy of the whole book, which I will put on the web. This one, the cover is a hybrid one. I think the ones which were there disappeared, but the information on here is actually the one. So you have to get these two books from the library and read them from the beginning to the end. Those of you who were not there yesterday, our course is PHY 3112, Killed My Project, Electromagnetism. So the outline is out, I can't repeat it, I'm sorry. You will have to get it from the web. So I'll start from the first section, which is electrostatics, and straight away start with Coulomb's law. If you have an objection that I should repeat the outline, you can express your feelings. Otherwise, I can. So one, we are looking at electrostatics. And 1.0, we shall look at Coulomb's law. I know most of you say Coulomb's law. Coulomb is a Frenchman, and the French will not pronounce the M again, so it's Coulomb's law. What did I want to say? I can just quickly repeat a few things from yesterday. That is about the meeting times are important. That is Monday, 11 up to 12 p.m. and then today from 12 to lunch. Most probably here is where we shall be always doing our tests. And then Thursday from 5 to 7. I like this time so much because it is fun. We're all tired. Then we are no longer thinking of any more hassles of the day, and then we can just enjoy our relaxed lecture. So these are the times we shall be meeting. We'll be coming here in class. The notes will be on Mwere. Some videos are already on YouTube for last year. Then I'll make sure there are tests on Mwere and then also written tests and written assignments, and also Mwere tests and Mwere assignments. Please remember, some of us want you to pass, but we don't have marks in our pockets. We look for all opportunities of getting new marks, including spending sleepless nights making for your objective questions. And then when I put them on Mwere, you refuse to go there. And then when you are there in town, you are swagging. You know, at campus we use e-learning. We pay technology fee and we use computers at Mac. And then when you come to my office and I say, you type in your password, you are like... Then you look for another key. Finished. You know, this life is very interesting. So that's the one thing I wanted to highlight. The other thing is the two links, which are so important. On this link, you'll find any textbook. Any text, whether in history, chemistry, geography, physics, mathematics. It is scanned, it is posted there, it is free. So you don't have to use any more excuses that the teacher was only giving us some few, unwritten notes we can't get. Find the references here, including my course. I don't mind whether you download where I'm going to get questions for exam. If you can do that, you should pass. Then the other one is where you can get my videos. But this is tricky because the university blocks YouTube during the day, so it is off from 8 a.m. to 5. Otherwise, before 8 a.m. and after 5 p.m. the link is open. The reason is that when you think everyone who goes on the internet is just going to watch movies of music and the like, not knowing that YouTube is used for video lectures and the like, and most universities post their videos on their channels, those are the problems you got. If your father used to jump the fence to go to the club, be sure that he would always be looking out for on the fence where the opportunities of you jumping, because he used to jump. And they say that if you want to protect your money, give the job to the thief. He will protect it because he knows how they steal it. So this one, if you can, in the evening, you can open it up and check out some of the video lectures which I have posted on the channel, and I think almost over 27 video lectures, and including some of electricity and magnetism, like the Rules model, which is a bit, it was interesting by that time. The course up to Maxwell's equations will be sort of a review of electricity and magnetism. It's after Maxwell's equations where we shall really do electromagnetism. So I will go on now to Coulomb's law, whereby we know that when we have two charges linear by each other, there is always a force between them. The force may be repulsive force, or it may be attractive force, or it may be a force of repulsion or a force of attraction, depending on the polarity of the charges. Although, when we go to this,
so for the case of Tuesday, that leg is colliding.
So, it is an electric, it will go out.
That was yesterday.
I said that I talked about that yesterday, that the timetable was made by the college collective effort. Okay? And this college collective effort agreed that this is the final timetable. It was agreed upon by the representative of physics, it was agreed upon by the representative of mathematics. So when that happens, I don't know the nature of in physics, this course is a core. In mathematics, it's an elective, and you have to agree with your lecturer of mathematics. The mathematics lecturer cannot change things in physics. Okay? I don't know whether you get the point. Last semester I had the same issue with some students who were in second year and they were doing the first year course. And I told them, if your mathematics lecturer is not flexible, your head is not going to help you, then you will do it next year. That's it, and I meant my word. Because the timetable is made, it is given to me. I come to class. Why should I hassle changing for you? Because we are a service, the physics department was a service department for the mathematicians for that course. And if you are being serviced, you should follow the service memo. So I think I've rectified that. I have nothing to do about it, so discuss with the math guy, and we should be able to get a way out. This is how these times were the same last year, they are the same this year, so I don't think there is any problem. But the other easy way is you can opt out from the course. I get a little number so that I mark in time and also enjoy. The fewer you are, the better. Last year I sponsored the party on my money, small money which I get. Because the students last year were really cooperative, not like these girls who sit alone and decide to gossip. Sorry, ladies, because if I say girls, you may. That's interesting. You see, females are very interesting people. When they are young, they want to be called big. If you met like a primary girl in P7 who has started getting new things and you say, you young girl, say, whom do you call young? And when they grow and they become rich in 40s and you say, how old are you? Hey, are you going to make me old? So I'm sorry if I use a wrong word, but you should mingle around. You shouldn't create gender imbalance in my class. Okay? And you shouldn't put gloomy faces because mention their names. And to put the record straight, I've never changed. My principles are tight. I never loosen out. Maybe when my back becomes a little bent, that's when I may loosen out and say, okay, do what you can because I can only follow up. So if you have two charges, either you can have them repel if they have the same polarity, or they can attract if they have opposite polarity. Although when you go to magnetism and you are looking at two similar currents, they tend to have a field which when it interacts, this field which will be now moving this side, here it is moving up. So here you have opposite fields which tend to repel each other, which tend to attract each other. So like currents attract. And I guess that's what these social misnomers of these days use probably to defend themselves. I am a lady, but you know I feel like a man inside. I don't know what they mean when they talk like that. You meet a guy saying, you know, I feel like a woman. That's why I put on earrings and these tight jeans. So, but don't tell them to use that excuse, that physics allows them to do that. Otherwise, the Honorable Bahat and company and Pastor Sam may look for me. So, the force on a point charge Q the force on a point charge Q due to a single point charge small q, which is at rest, a distance r away in free space is given by from magnetism, electricity and magnetism, we said that this force F, and if I can repeat this again, my vectorial representation, this is my preferred. And that would be nice, it would be nice to me if I'm marking you in an exam or in a test or an assignment when you really follow what I like. And then, but of course you'll find in some books it is that, in other books it is this with a double-headed arrow. In other books you find there is a line at the bottom, a line at the top, and in most books it is bolded. I can't bold my vectors here on board. It would be really uneconomical and time-consuming. So this would be equal to the product of these two charges and inversely proportional to the distance between, and it should act in the direction of the action from which charge is bringing about the force. And we multiply it by the R cap, or sometimes which I was calling R roof. And R roof is called the unit direction vector. It is just a vector that shows the direction of the action force. So we are talking of having the single charge or a single point charge Q, which is acting on the charge Q, capital, which are at a distance R from each other or away. And this force that Q small is acting on capital Q is along the direction R cap. So where R cap is a unit direction vector along R. It's just unit direction vector. It's one, its magnitude is 1, and then it shows only to show you, to help you see where the vector is acting along. That's why we call it unit directional or direction vector. So before I continue, these two books have this other one has chapter 1 and chapter 2 on calculus, that is vector calculus. Introduction to Electrodynamics has the whole of chapter 1, which is vector calculus. So chapter 1 and 2 for Lorraine. This is vector calculus, whereas chapter 1 of Griffith is also vector calculus. So you need to read them to remember to get acquainted with Gauss's law in terms of when you talk of divergent theory, when you talk of the Stokes theory. What are you talking about? When you talk of indirection vector, when you talk of the dot product, cross product, what does it mean? When you talk of carrying or making a car of a bunch of film lines. You have the film lines outwards and you try to curl them, to make them curl. That's why we say that if this is our electric field intensity, when you now try to bend these field lines, then you end up having no field line, no electric field intensity, because what was going out, you try to carry it up, and eventually you make it disappear into one point. Do you feel any electric field around? And that's why in electricity and magnetism we had the curl of E being the same as 0. The first chapter of vector calculus teaches you all that, which I can't do. You did it in mathematical physics, you did it in vector calculus in mathematics, and you should be now experts to read through just to get acquainted with these principles. So thus, if charges, so here we only had one single charge, just like society. God was alone, he became lonely. Then he created Adam. After creating Adam, Adam complained that he's lonely. Then I hear from the bone of Adam, he created the wonderful Eve. Eve discovered the fruit, and then they produced, who were their children? Cain and Abel.
Yes.
And life, continued. It started with one. Now the society, the way the society was when it was only Adam and Eve, they interacted. Sin, and then produced Cain and Abel. After producing Cain and Abel, dynamics changed. I don't know where they got their wives. Those of you who are good believers can enlighten me. Where Cain and Abel got their wives, or whether they went back to Mama. Then they produced other children. After producing other children, I have one strong believer who can, if I go wrong somewhere, you will correct me. Thus, after we are having only these two charges which are interacting with each other, let's now talk of if we have other charges, Q1 and Q2, and then we talk of the distance at a distance R12, R12 meaning that a distance from 1 to 2. So now we are trying to be as specific as possible. So I'm going to draw it as we have our charge. So this is depends on how you want to look at it. This is R12 direction, and this being the direction R21, and we have our charges Q1, then Q2. I'm being too slow to make sure that I make the first point sink home. I'll get an opportunity on where I will be able to rush and use marathon. Okay, so let's look at the force. The force on Q2, so it should be the force on Q1 due to Q2 is given by, this is just relative, like if I stood with him, he's taller than me, so you may choose to use him. You say him is taller than BFT, or you can say BFT is shorter than him. That's what I'm trying to do. That the force on Q1 by Q2, we shall write it as F21, because it is the force on Q1 by Q2, so it will be F21 is proportional to the product. So we say is equal to K, product of the charges. Maybe I didn't state the Coulomb's law properly. Coulomb's law, because this is a review really, is that the force is proportional to the product of the charges and inversely proportional to the distance between, and takes in the direction of from one one charge to the other. So if I'm looking at the force from on Q1, not on Q1, by Q2 on Q1 would be the same as 2, 1 here. And of course we will be looking at the distance from 2 to, but this doesn't matter, even if it is from 1 to 2, it is about the magnitude between these two charges. So for magnitude, we don't have to bother ourselves. So this would be divided by R12 squared, then R21 car. So I guess that one makes life easy for me. And if I write the next one as still R12, you now know the reason, because we are looking at the R, either 2, 1 vector magnitude. And because when we square the 2, it's R21, that R21, which would be the same as R21 or R12 squared. They are parallel to each other. The cosine of them is for the angle between them. If you are parallel to each other, the angle between you is 0. So you will be having magnitude of 1 of itself times the magnitude of itself, cosine the angle between itself and itself, which is 0. So of course 0 is 1, and you get the other value. So that's what it means, that the force of charge 2 on Q1 is along R21, that last part of the expression. Because it is the force on this Q1 exerted by Q2 on it. Either it is attraction or it is, if it is negative, it means that it should have acted the other way, so it would be attraction. If it is positive, when you pointed it this way, it means it repelled it. So they were either all positive or all negative. And the force on Q2 due to Q1 is given by F12 is equal to still K, product doesn't matter, Q1 times Q2 is the same as Q2 times Q1. We say that the product of, or the square of this distance between remains the same, either if you walk from Q1 to Q2 or if you are measuring from Q2 to Q1. So there is no reason why you shouldn't be confused by this placement of 1, 2, and maybe expecting that this should have been 2, 1. And of course this would be from charge 1 now is the one which is acting on Q2. So this would be 1, 2, and it's a unit direction vector. It has magnitude 1 only for the purpose of making us know that it is pointing in this direction. Any question? Okay, so we have that where the constant K, is equal to 1/4 pi epsilon naught. If substituted in, you get 9 times 10 the power 9 Newton meter squared per Coulomb squared. And the other constant E is called the permittivity of free space, and it's got the value, epsilon naught has the value of 8.85 times 10 to the power negative 12. If you made the epsilon naught, if you made this, just to remind you of your dimensions and how to use dimensions to get the units, we are having F being the same as Q1, Q2 over 4 pi, epsilon naught. The other one is the unit direction vector. So these are newtons. These are Coulomb squared. This is dimensionless. This is epsilon naught. And then we have the other square. These are meter squared. If I put the epsilon naught here, it will be the same as Coulomb squared. And then 1 Newton meter squared. So if we now looking at the, of course, if I had put this whole constant k on this other side, it would be, we would be having newtons equal to Coulomb squared divided by, you have the k here, and then you have the meter squared. And that's why we say k is having the units of, Coulomb squared, newtons, meter squared. So our k will be equal to per newton. Is it true?
It is 1 over k.
It is 1 over k. Ah, okay. No, it's not 1 over k. K is 1 over this.
So k should be
K should be what?
this is square.
The constant. Yeah, this is square. Constant.
This is square.
What do you mean by K is
K is equal to this is square over m square.
I'm following this expression. Ah, okay, K is up, sorry. Okay, so K is here, so we shall have our K being the same as Newton meter squared. And then divided by C squared. So we ended up having its units being the same as newtons, then meter squared per Coulomb squared. So we can derive these ones the same way, that it would be equal to per Newton, and then we have Coulomb squared per meter squared. So we say these are Coulomb squared per Newton per meter. So there is no reason why you should fail to get units of a given quantity when you are trying to derive something. Guys, we were together. We should be used to momentum, to magnitude and quantity, the bar. So, we now know how the two charges interact, okay? We are now comfortable with how two charges interact, and we don't need to bother. Only thing we need to know the basics of charges and how they behave near each other, and like attract, like repel. You see, these days I'm finding it hard to use society to explain the attraction and the repulsion because of these issues of modern society. So I find it so hard to say that like repel, you know, like I used to say in my magnetism that like poles repel. I may get one guy who is confused and says no, but we attract. So, but still, if I can follow the moral society, the Bible way, if you since Sodom and Gomorrah were destroyed and the world turned into salt, I can still say that like repel and like attract, unless otherwise. So if we now have a bunch of charges, now when you, normally when you are a family, when you start as a girlfriend and boyfriend, you know, attraction is too high and you don't have any distractions. When you get married officially, the relatives start interfering. When you produce children, then actually the father starts complaining that now the attention is on the kid. And he says, but nowadays all the time you are just with the kid. Then when the kids become many, the firstborn now starts complaining of the secondborn. Now I no longer get the sweets, they now give the other one. ETC, because now the vicinity has become changed. So when we had two charges, we started with a test charge, Q, brought in a single charge, got some forces about it, and Coulomb helped us on how these interact. Now when we got two charges, Q1 and Q2, we now concretized on how the force acts from one of the charges to the other by, you know, getting now the nomenclature of 1, 2 and the nomenclature of 2, 1. How about if we get a bunch of charges now? We are now graduating from 2 charges to a couple of charges. 1, 2, 3, up to n. How do they interact? It's hard to say, we say Coulomb's law, but Coulomb's law is acting on any 2 individual charges. But this, imagine when you are seated here, your thoughts are very diverse. This one is thinking the other one maybe is this one is thinking the other one maybe he hasn't paid fees and they opt out. You can't single out which charge is interacting. You can't say you only interact with the other one. I cannot say don't like that guy, no. I have no choice. So we use another principle, which is the principle of superposition. So this would help us now to know how these charges are interacting. How do these charges interact with each other? So the electrostatic force, on the charge Q, due to a distribution of point charges Qi, where I is equal to 1, 2, 3, and so on up to n of them, at position Ri from the point charge Qi, from the point charge so this point charge is our point charge Q. So let's call it Q naught. So change here to Q naught. From the point charge Q naught at position Ri from the point charge Q naught So this electrostatic force on this charge is a vector sum of the forces exerted individually on Q9. Now, when you come here as a god in first year, by the time you leave in third year, you leave when the knowledge you have is a vector sum, or we can say is a sum effect of all the individual knowledge you have gotten from each of us, the people who will be lecturing you. True or false? False. Okay, since you were not there yesterday, I can explain one thing I talked about. Our education system, I guess, is 100% nice. Where is the problem? The implementers. And the implementers are we, the teachers. If I come here and all I'm singing is how you are going to see this number in exam, which I have never done, then you never know why you are studying electrostatics, or magnetism, or quantum physics, or statistical physics, blah, blah. Some of you don't know when you do your mathematics, you can end up in an insurance company and be able to iterate the accidents, minimize the risk, calculate the profit in case there are no accidents, know how the premium should be paid. If I teach you electromagnetism and I never tell you that you are using electromagnetic induction here, we are using the force on the conductor in that fan to turn the motor, and then we get the coolness in here, physics would be useless. But the best example I gave was the matoke. Matoke is cooked almost in a bunch of different places in this country. The Baganda like to steam it up, spend, I don't know, how many hours do you spend to make some matoke already? How many hours? It doesn't seem like any one of you has ever made some nice matoke. Like they put in these leaves, smash them, make them look nice, and then finally, the other week I asked for wombo from a restaurant. This waitress brings my wombo, opens it up, pours it on the plate, and took back the leaves. I say now this is no longer wombo. I wanted to enjoy it from the leaves. As I look at the leaves, when you scratch on the other parts near the leaves, the green thing comes out and you feel that you are eating wombo. But when she put it on the plate, she even took away some of my, which I could have scooped with a spoon. She took back. So people here would like to make matoke, which is really, and then steam it up, and after preparing it at lunchtime, from around 10, you eat it even at supper at 4 or 5. Then and it takes only about 15 minutes to finish it, after spending all that time. For us, we peel, after peeling, put in water, pour away water, smash, eat. Because we just want to put in the stomach. And if we don't have that time of smashing, we just chop them into pieces, boil them. When they are ready, we get the other beans which we had made, pour on top, put in some spices, eat. So, when you go to a joint where they make some chop, they just put on the fire, you come pogola. You remove the cover, chew, same matoke. At least in sciences, Nericon is a UK published book, isn't it? Bostock is published by UK publishers. Scholars, actually, not publishers, but scholars. It is meant for the market in Europe and anywhere in the world. So you can't say that the book Nericon is bad, no? Nericon is good, but I told one of the colleagues that I only saw the train when I came to Kampala. But in A-level, I was expected to calculate momentum questions involving collision of train tracks and pass them well. I don't even know how the railway track looked like. So do you expect to do much? You study about buoyancy, even when you have water at home and a basin, you have never made anything to float. At home, you say upthrust, but you have never put anything in water to float and say upthrust. When you open a cistern of a toilet, there is a buoyant material, some ball like this. Simple technology, which has a lever, and as water is filling up, it lifts this one up, and then something here pushes something to close the tap, the valve, and water will stop there from flowing into the system. You flash, water goes, this one goes down, water fills up, lifting this ball. But the teacher has never seen this system. He can't talk of where upthrust is being applied, where buoyancy helps. And then you blame the book which talked about upthrust. And then you find even educated people saying, this education system was fake. How did you come to know it is fake? Your fakeness, you shouldn't blame it on the system. It is your fakeness. Both the learner and for example, you find parents always wondering, I don't know how what happened to my children. But you were a child once, can't you reflect back? Me, I was stubborn sometimes when I was young. There are things you wouldn't tell me to do if I don't want. I never used to have anyone to wake me up to go and read, but I would wake myself up anyway. If you came to wake me up and I tell you I still need 30 minutes, I meant it. I come here at 6:30 every day. No one can say, well, tomorrow come early. No, I know. I've always attended your lectures at a clock. Time is starting, I'm here. I don't need anyone to tell me that. So if you could help me and explain to your fellow teachers and fellow students, our education system is good. But the problem is you guys grow like grass. I said it last year to the last year group. You know, grass just grows, others step on it, others come and trim it, others pull it, other cows eat it. But if you really had the purpose, I don't think I would even having any trouble if you had a purpose in this world. The other day, a student bumped into my room and is like, excuse me, sir, there were two. One was education and science. The one of science is asking me, sir, I have gotten the admission letter, but I don't know whether it is, this course is, I don't know anything about this course. So I said, who applied for it? He said, it is me. Why did you apply for it? It was a list of courses to apply for. Are you on government or private? On private. I looked at the poor man who is going to pay for something he doesn't know. But it's a good course. It's a course, once you finish it, almost 90% of members here in the department did BSc. Proceeded for Masters, PhD, and are teaching you. I did education, and I'm teaching in the corners. Because I did almost all courses in the corners, as you are doing. There's no difference between you and someone who's doing a BSc, if you are doing education. Only that for you, you are even going and learning how to impart the knowledge you are getting into other people. And also graduating as a certified professional teacher. That you know how to handle students, you know what pedagogy is, to mention but a few. So I think I didn't want to make your life hard, since on Thursday we have more time to talk and cover much. I will proceed from here on. And Thursday, by the way, if you cooperate, I can twist it and start earlier and earlier, or if my camera and my battery is good, we can still go on up to 8 and you miss Malam and go to Chumi. So Thursday will be the nicest time, and then next week we shall start on practicals. So start reading through the manual this week. There are a couple of practicals which are not functional. I may need to know how to make them functional. Yesterday I didn't grab you when you were here, so I may need to know those who were here today, so that I can do more accountability. And so, let's cooperate in this course. If we become cooperative, this course will be the simplest. If you screw me up like you did in electromagnetism, by having your phones talk around and ring around, you know what I can do. And I think either it is you who has an register in my office, the one in the front. Sure, you came to my office and register. And Father. Okay, so you make sure you come. Those of you who have a register, there are two lists. There is this list, and then I have another list in the office for the machine. You register, and then tap on the machine. Please come and we register. 2. I have only one student on web. I give you another chance. By evening, you should be on web. If you forgot your password, it's very easy. You should start with your email. Get the password of your email, which you can get from the web administrator, either school or college here in Jika. Once you have gotten that email, you go to Mwele and say forgot that you forgot. Instead of logging in, you say forgot my password. It will ask you the email that is associated with your Mwele account, which probably should be a university email because I was very strict. So you put in your email, it will send you a notification in the email. So it's like you have one tab open for Mwele, another tab for email. So you check on your email and you will find an email from e-learning unit, and then you click on the link. It will say continue, then it will give you a new password, and then you have already your username. If you have a username, on the part where there is email or username, you can use your username. But if you get problems, please let me know, because almost all the notes will be on the web. I will give assignments on Mwele, both assignments and tests. I want you to pass. And also get some skills. You know, you don't go in the field and when they are talking of computers, you start saying, you know those things of electricity. And you pretend that you already know, but you know where your problem is. So you know those things of internet is not good for you. So enjoy your life.
Yeah.